Starting 1.4 notes, which is about perimeter and area in the coordinate plane. But before we get to perimeter and area, let's talk about polygons. So polygons are figures in a plane that have segments for sides. So a circle can't be a polygon. They have to have straight line segments for sides. We call the sides sides. And the point where these sides meet, put like a little point here, the points where the sides meet are called a vertex or vertices if there's more than one. Notice also how we name the polygon. So we say polygon, and then we name the vertices of the polygon. So we could say A, B, C, D, E. We could say A, E, D, C, B. We could even start at any letter, like we call it D, C, B, A, E. But we say the letters as you go around the polygon in either clockwise or counterclockwise. Now, when we talk about polygons, we usually talk about them with the types of polygon is related to how many sides it has. So we're very familiar with triangles, 3 sides. But then you should also become familiar with these other types of polygons. Quadrilateral, 4, pentagon, just like in Washington, D.C., 5, hexagon, 6, heptagon, 7, octagon, like an octopus, 8, nonagon, 9, decagon, 10, like a decade is 10 years, or a decathlon, and a dodecagon, do meaning 2, and then deca meaning 10, 2 plus 10, is 12 sides. Now, if it's anything else than these, then we just say, like, let's say if it had 14 sides, we'd call it a 14gon or a 28gon or something like that. Finally, a polygon is convex when no line that contains the side of the polygon contains a point in the interior of the polygon. A polygon is not convex, is concave. So what I like to say is if you can connect any 2 vertices in the polygon, like here we're connecting vertices, if you can connect vertices and it stays inside the polygon, then it is convex. If you could connect 2 vertices like this one and the second one, see how when we connect those 2 vertices, it's outside the polygon? Then it's concave. I always think like caving in. Caving in is like going into itself, and that's what's happening there where I drew that segment. It's kind of like caving in there. All right, so we're going to practice this. We're going to classify each polygon by the number of sides, give it that name, and whether it's convex or concave. So you can pause this and do it on your own, and then push play in a minute. All right, so this polygon has 1, 2, 3, 4 sides, so it's a quadrilateral. And then it is concave because, like, we can connect those 2 vertices there, and it's outside the polygon. This one is 1, 2, 3, 4, 5, 6, so it's a hexagon. And it is convex. If we try to draw any 2 vertices here, we're connecting, it will always stay inside. Oops, that was kind of curvy, but you get the idea. All right, so next we have perimeter and area. Now, perimeter for any figure means you add up all the sides. It's the rim. It's like the rim and perimeter. It's the border. And so for any of these figures, the perimeter is you add up all the sides. But now for the triangle, the area is something special. Because it is a triangle, it's 1/2 base times height. And here's the base. And notice here's the height. The height is not a side of the triangle, but it is straight up perpendicular to the base. So I'm going to say height is always perpendicular to the base. In other words, it makes that right angle. And so with triangles, that's what we call an acute triangle with all acute angles. But we could have a right triangle, and there. This would be the height, and this would be the base. Or we could even have an obtuse triangle, where in this case, this is the base, but then the height, again, it's straight down from the vertex where it would meet the base. That would be the height. Sometimes it's outside the triangle. Sometimes it's a side of the triangle, like in a right triangle, or sometimes inside. Now, the rest of these figures, the square, the rectangle, and the parallelogram, all have an area that you could describe as base times height, where the triangle is 1/2 base times height. These could all be base times height. So square, base times height. It just happens that they're the same. In a rectangle, I don't know why they all of a sudden switched to length and width, but it still could be base times height if we call the one base and the other height. And then parallelogram is base times height. Notice again that height is perpendicular to the base. It's not a side of the parallelogram, but it's inside the parallelogram that's perpendicular. Okay, this is the longest problem. I'm just going to tell you right now, this is the longest problem because it's going to involve some work. We are going to find the perimeter and area of triangle DEF, and let's plot these vertices. So D is at 1, 3, so 1, 3 right there, that's D. E is 4, -3, so 4, -3 is right here. E and F is at -4, -3, so -4, -3, oh, right here, right there, F. So we are going to connect those points to form a triangle. Now, first we want to find the perimeter. And so we need to know what all the sides are. Now, first of all, this base, that's kind of easy to figure out because a straight line on the grid goes from -4 to 4. So that is 8. The question now, though, is what's FD? Like, what's this one over there? Well, to do that, you could use the distance formula that we learned last time. Or I think it's a little bit easier to maybe, like, square it off and use the Pythagorean theorem since we have a right triangle here. Now, this side looks like it's 6. This side is 5. And so this would be, so we're going to say 5 squared plus 6 squared equals DF squared. So 25 plus 36 equals DF squared. 61 equals DF squared. And then we have to square root both sides. Now, square root of 61, that's just it. We can't, 4 doesn't go into it, 9 doesn't go in it, so that's it. So we found this, and so this now is square root of 61. Now we need to find DE, so let's do that. So if we rectangle that off, this is 3, this is 6, like the other side. So 3 squared plus 6 squared equals DE squared. 9 plus 36 equals DE squared. 45 equals DE squared. And we're going to square root both sides. Now 45, remember, is like square root of 9 times square root of 5, where 9's a perfect square. Oops, so we're going to get 3 square root of 5 is DE. So back to the top. Our perimeter then is going to be our base 8, our side FD, which is square root of 61, and our last side DE is 3 square root of 5. And so that's all we can do. That is all we can do. We can't combine those because square root of 61 is different than square root of, or 3 square root of 5. Now, let's find the area. So the area, we need base times height. So the base here is 8. Now remember, the height of this is going to be there. That's going to be my h. So the height, we can see, we can count straight up. It's on the grid lines, is going to be 6. So 8 times 6. Oh, I forgot the 1/2. It's a triangle. So 1/2 times 8 times 6 is going to be 24. So that is going to be our area. Now for this next one, we're not going to do perimeter again. We just had a lot of practice in that. We're just going to find the area. So let's see. G is -3, 2. -3, 2 is right there. G. H is 2, 2. H. And then -1, -3 right here is I. So we're going to form that triangle. Now, the question is, we're going to do area, which is base times height. Now, does the base have to be on the bottom? No, the base could be GH right here at the top. And if that's the base, then I'll draw the height in red. This would be the height. It's going to go from the opposite vertex perpendicular to the base. Well, let's see. This base is 5. And the height is 5. Oh, and it's a triangle. I keep forgetting. Let me back that up. Don't you make that mistake, right? It's 1/2 base times height. 1/2 base times height. So this is going to be, we could write 25 halves, or we could write 12.5, or we could write 12.5. Those are all acceptable answers. Finally, we have a non-triangle. We have parallelogram, JKLM. So let's plot that. Oops. J is -3, 5 right there. J. K is 1, 5. L is 2, -1. And M is, -2, -1. There we go. So we can see our parallelogram here. So we are going to look for the area. We're also going to do the perimeter. We are going to do both. So area and perimeter. Okay, let's start with the area. So for the area, we know that this is 1, 2, 3, 4, and 4, right? That's our base. Now for our height, we need like this. So this would be our height. It's perpendicular to the base, and let's see, 1, 2, 3, 4, 5, 6. So our height is 6. Our base is 4. So the area is going to be 6 times 4, or 24. So that was pretty straightforward. If we want to find the perimeter, we need to find these sides, which are the same, right? They are the same. So let's use that height I just drew. See how it made a right triangle? And the side that we want is the hypotenuse. So we just said that one side is 6, the height is 6. This other side right here would be 1. So 6 times 1. 6 squared plus 1 squared equals KL squared. I forgot what we were doing there. Okay, so and that's not the perimeter. We need to find KL. Finding KL will help us do the perimeter because we know 6, we know 1, got to find KL. So this is going to be 36 plus 1 equals KL squared. 37 equals KL squared. Square root both sides. And we get square root of 37 equals KL. So this is square root of 37 This over here is the same, square root of 37. You can see it's going to be 6 by 1. So our perimeter is going to be 4 plus square root of 37 plus 4 plus square root of 37, which is going to equal 8 plus, now square root of 37 plus square root of 37. It's almost like x plus x. It's going to be 2 square root of 37. And so that's the perimeter.